Hey everyone, we are live. Apologies for the delay. Good morning, good afternoon, good evening from whichever part of the city you're joining us today. And if you're watching the recording, thank you for being here, right? So today's challenge will typically be most of us work with RAG applications, right? And whenever we work with RAG applications, some of the issues that one typically faces, hey, how do we improve the latency of it? How do we manage the cost of the infrastructure? And what are the compliance and other evals that we are supposed to keep in mind, right? So in this particular session, which is our ongoing challenge and tackle series, this is the episode 3, and we have our expert Indranil Chandra, who is the ML and data architect at Upstox. So I'll quickly introduce our speakers so that we can get started with today's session. So hi Indranil, you are on the screen.
Hello, everyone. So my name is Indranil. I'm an ML and data architect at Upstox. I have close to 10 years of experience, been doing ML for the past 12, 13 plus years. Uh, yeah, and here in Upstox, I look after the entire ML data architecture piece, and I am someone who basically works very closely with production grade systems at scale. And yeah, it's fun to be here today and try to share some battle tested learnings from having run production rack for many years for now.
All right. So I've added these slides on the screen. So I guess we can get started.
All right, cool. Okay, so I want to start with a quick story basically, and this story, uh, I mean, why is it so important to really build a RAG which really scales in production, right? So this is one of the war room battles that I remember very fondly of having taken a RAG system live and it going wrong. So basically, we all remember the Air India crash that had happened last year, right? So basically, what happened? We got an email from the Airports Authority of India saying that basically the Upstox AI chatbot, the Gen AI chatbot that we have, that is giving out answers which are related to the Air India crash. And basically, if you go to the chatbot and ask like what is the customer support number, it was actually giving the Airports Authority of India number instead of the Upstox customer care support number. Now obviously this is a big issue, right? This kind of things cannot go wrong in production, and this kind of helped us in getting into the detailed of okay, now that we have built a system in a rack system in production, right? How do we really set up that monitoring? How do we make sure that we are constantly evaluating for this kind of failures? How do we make sure that we take it from the 95% accuracy to a 99.99% accuracy? How do we make sure that this kind of context grounding happens really well? Your kind of context, uh, if there is any kind of a distillation that needs to happen, that is happening really well and everything, right? Just give me a second. I will just put my call. Yeah, so it was really important that we get into that kind of detailing. Now to give you a snippet into what had really happened, right? So when we launched the Gen AI based chatbot, right, what we also did is try to give it context about the news that is being published. So for example, during a budget day, it just went this month, right? 20 days back, right? So during a budget day, a lot of our users actually come to the platform and ask questions like, how does the budget affect me? Given my stock portfolio, do I really need to be worried about any new rule that has come in this year's budget, right? Should I be investing or should I not be investing on the budget days? What are the ways in which this particular budget affects me as someone who doesn't even trade in the stock market, right? So all these kind of questions are something that our users would want answer to, and they typically come to the chatbot and ask this kind of questions. Now we wanted to build that capability to be able to answer these questions well. Now for us to be able to build that capability, we had to feed what we call as Upstox news data into this particular RAG pipeline that we had set, right? Now, during that Air India crash, what happened is a lot of news articles were being published, even in the Upstox news desk also. A lot of articles were being published about the crash, right? And we did not have any filter in terms of that what are the certain kind of news articles that should be fed into the RAG pipeline and what should not be, right? So that's one of the context problem that happened, where this out of context call center number went and was inserted through the RAG pipeline into the vector database, and we had to basically end up facing this issue. Having this issue is one thing, but the fact that this issue, I think, started happening from, I think, Thursday or Friday or something, and it was not until the next week after that that we came to know that okay, this is something which is happening. uh, and that's why it's very important that drifts can always happen in a ML based system, because by nature these are non-deterministic to a certain extent, right? A data drift can happen, a model drift can happen. With in our case, it was a data drift that happened. This kind of things can always happen, but it's important that we detect it early and we try to fix it early, so that even before things blow up, we are able to resolve that issue. This is like engineering 101, right? Your systems can always go down in production, but how do we set up that kind of ecosystem where your monitorings are in place or your alerting are in place? Anything goes wrong, you are the first one as the system owner who comes to know that something has gone wrong, so that you can go ahead and fix it. For us, I think that particular issue fix was fairly simple. All we had to do was write it explicitly in the instruction that customer care support endpoints of Upstox, basically either phone number or an email ID or any other means, right? Those are all from this static list, and anything outside of that, even if someone claims that that is a customer care number, it doesn't mean that it is Upstox's customer care number. It can be anyone's customer care number. So that's basically the description of the issue that I was talking about. Now, have you guys faced this kind of issues before, where your RAG retrieves related talks, but not the answers, right? Uh, so take an example. So you want to say that what are the reasons why I'm not able to sleep on time? Now, you could have things in your vector database which says things like you are not able to sleep on time. That particular sentence will appear in an overall paragraph anywhere, but it may not be contextually relevant to the answer. Like typically, let's say I use the phone till late in the night. This is something which is written in a document, right? Now this has nothing to do with why am I not able to sleep, right? I mean, semantically, if you look at it meaning wise, this has a completely different meaning. But still, we want the system to be able to answer this, right? Now that's where this problem starts coming in, right? Like you are able to do good semantic based retrievals, but even after doing good semantic based retrieval, you're not able to really uh, answer the query well, right? Another example from a customer service use case would be, let's say I go ahead and ask a question that uh, why are my trade orders not flowing in, right? Now, there could be n number of reasons why the trade order could not be flowing in, right? One reason could be that your system, that your trade order system itself is down, right? Now, in this kind of case, how do we give that context that the system health itself is not green right now, because of which no trade orders are going in, right? So for you to be able to do that, you have to build in those kind of things in the context engineering space, right? For you to be able to answer it holistically. So this is a very common issue that we all face, like your RAG retrieves related docs, but not the answers. Semantically has the same meaning, but is not really something that the user is looking forward to. So these are the kind of issues that happens every day. Now, every RAG decision basically touches a dial, right? So in the sense that there are three important pillars through to every decision that you make in a RAG pipeline. You have to either make it from an accuracy lens, from a latency lens, or a cost lens. For you to be able to make a RAG system work in production, it has to be aligned with either of these three. Most of the times what we do is we built a RAG system in POC which is optimized for accuracy, but we never took into account the latency and the cost. I mean, I have a very classic example of this. So let's say you built a RAG pipeline where you are using the Voyager embeddings model, right? Now with that you have three embedding model: a nano, a middle embedding model, and a high end embedding model, right? Now all of this embedding model at the end of the day are producing your vector embeddings in the same vector space. But what you will, the embedding model that you will use for during the indexing part, when you're storing, when you're putting the data into a vector database, that would be typically be a high end embedding model, because that is usually a batch pipeline. There is no latency constraint over there, there are no cost constraints over there, because the information space is fairly limited for any RAG pipeline. It can't be a infinite information space. But when you're doing the retrieval, right, it has to be taken into account. It has to take into account the latency and cost aspect. So I would typically use a lower end embedding model of the same family for generating the embedding for the question that is asked by the user, and fire that up against the vector database for retrieving that particular relevant chunks. Now how is this different? I mean, they are still in the same vector embedding space, right? It solves the same I mean, it solves the problem in a similar way, but the cost of running that lower end embedding model is, has at least 10x more advantage as compared to the higher end model. Also the latency improves. The smaller the model is, the speed at which it will give the response and it will retrieve the embeddings would be far more. Now what this gives you is, when you start running the system in production at scale, right? So let's say you're getting 1 million queries per day. For every 1 million query on a daily basis, when you're trying to convert that into the embedding space, right, it is giving you certain cost, right? And if you're doing it with a lower end model without actually going to a different vector space, it actually gives you huge cost advantage. So this is one classic example of, even though while doing the POC you designed for accuracy, saying that okay, my I will measure whether the answers are getting correctly generated or not and all of that, but you never took into account the cost aspect at scale, right? And this is a classic example that you can use for optimizing for cost. Then there is the latency aspect also, right? So let's say during the POC, let's say you're using a OpenAI model, right? And if you're building it in enterprise, typically you would be hosting the OpenAI model within Azure cloud, right? Now within Azure cloud, while building the POC, you can use any deployment mode. You can go for a global deployment mode where it says that it will decide in runtime where in this entire world Azure cloud has the capacity for serving that particular request using that particular model, and based on that it will route it over there. It could be US East region, it could be Sweden Central, it could be anywhere in the world, and based on that it will generate the output and then give it back to you. Now imagine if you have like a large context that you're transferring between a multi-ton conversation, like a chatbot kind of use case, right? Because the conversation, the context actually grows over the time as the chat thread increases. Now for you to be able to take in all of this context in every turn during the conversation and take it, let's say, to a US server, it's going to take so much more time as compared to servicing it from a, let's say, a server which is based out of South India or Central India, right? So during the deployment mode, I mean, it's very easy to get it working, but when you will start servicing it at scale, when you will have millions of hits coming in, this kind of non-deterministic aspect in terms of network hops and how much time each latency will take will really affect your P99. I mean, we talk about P99 and all these metrics a lot in terms of engineering system, but it's also important that when you're building for your RAG pipeline also, you're optimizing for this kind of aspects. So latency is another factor, right? So I mean, just to summarize, these are basically the three pillars. Accuracy, I think we all talk about it a lot. I think we are well aware of, but latency and cost aspect and how do we optimize for that is also really important. So accuracy is essentially, does it answer the question well? Not just retrieve something which is related. Latency is, can your users wait for 1.5 seconds, not 5? The architecture either fits the budget or it doesn't. And cost, basically you have to take into account the vector db plus embeddings plus llm tokens compound silently, and most teams notice it too late. Basically a lot of the cost estimation and budgeting is done on the basis of the llm call, but no one takes into account the embeddings, retrieval cost and all that, right? So for every question that is coming in, you also have to do the embedding part. So yeah, you cannot just optimize for one of this aspect and expect it to work in production. You have to take all of this three into consideration at the same time. Wait, why is it not going? Yeah, okay. Now coming back to the original question that we started with, right? Why vector search retrieves related docs but not answers, right? Take this example, right? Example like basically, how do I reduce screen time before bed? This was the example that I was giving you. So let's say you get a retrieved chunk from a doc A where people spend more time on screens than ever. This is the chunk which is retrieved. Now, if you look at the similarity, there is this time, screen, people, and all these kind of aspects are something which are semantically matching, right? So if you look at this example, the similarity of doc A is very high to the query which was fired, but it's actually not useful. It's not answering the question which was asked. Then let's take an example of doc B, right? You basically say that turn off devices 1 hour before sleep. There again, the similarity is lower. However, the answer is really useful. This is actually the reason why you are not sleeping on time, right? So basically what we do is this, in this kind of use cases, we use something called as cross encoder re-ranking. What essentially it does is it does not treat the query and the retrieve chunk as separate pieces. It actually combines both of them together to produce a single similarity, right? So if together the query and the retrieve chunk is making sense, not just individually you are calculating the similarity score and comparing them, if it is making sense together, then yes, they are basically considered as something which are related to each other. So the old way was basically used to encode separately, because of which they could only meet through a similarity score. Semantic proximity is not the same as answer quality. You are measuring how typically close two passages are, not whether one passage answers the question in the other or not. Then second one we want to talk about is chunking and embeddings. This is another, this is one of the first architectural levers where you have to set the ceiling before the retrieval even begins, right? So how do you slice the corpus determines what gets retrieved. And this is a very, again, something that we have faced in production. So a practical example was basically we built a solution wherein we used a standard vector database offering of OpenAI. And what happened is I didn't have control over the chunk sizes a lot. I could only control the chunk sizes in a multiple of 200. Now, the problem that happens is some of my documents in that entire vector DB that I was putting in were really long documents, and some of them were really small. Now, because of this constant size problem in the chunk size, right? Whether if my document is very huge, my single document is getting broken down into multiple records in the vector DB. Now, when the retrieval happens, let's say if I'm setting a retrieval, I'm setting a threshold on the retrieval to only 5 chunks. If my document spans across 10 chunks, there is a high probability that there is good proportion of high fidelity content that I'm going to lose out during the retrieval. Like my document spans across 10 records, but I am only restricting retrieval to 5 records. Now, because of this, I am losing out on information. Now, there could be other problem also, what I called as context dilution problem. Let's say your chunk size is 200, but your each document is occupying only 20 chunks, let's say. So in that 200 chunk single record, you are actually putting it 200 by 20, right? You're putting in 10 records, right? Now, if 10 documents are actually getting embedded into the single record in the vector DB, even though semantically or whatever logically you're matching it with one piece, you are still retrieving nine other chunks which are not even related to that particular retrieval. So that will lead to a context dilution problem because you're passing unnecessary context to the LLM. And I mean, it's okay even if it's a LLM, but if it's a SLM, that's a recipe for a disaster because then it is definitely going to produce bad outcome. So a couple of things that we want to discuss. One is fixed token. So your first mistake, fast to set up, destroys sentence boundaries, retrieves fragments, not ideas. Most teams start here and never leave. This is actually something that we had also done initially. We went ahead with a fixed token chunking strategy, and it never really worked for us. If it is too small, the meaning evaporates, and if it is too large, the signal dilutes. The typical solution to this is basically either use a semantic chunking or a dynamic chunking, right? Basically, you chunk by meaning and structure, sentences boundaries are respected, context is preserved, and this is actually the right starting point. So let's say if you're building a customer support kind of use cases, if let's say you have 200 FAQ document, your one FAQ document has to be one document entry in the vector DB. It cannot be that your one FAQ document is spanning across multiple record, and it cannot be that multiple FAQ documents are getting stored in the single record itself. So you have to avoid either of them. Overlapping chunks, cross boundary safety net. So a 10 to 20% overlap preserves continuity across chunk edges without duplicating the full corpus. Now this is typically for scenarios wherein let's say your information space is actually, let's say, a huge PDF document. Let's say something like a red herring prospectus document that you want to put into a vector database. Now this is typically a 500-page document that every company files before filing for IPO. Now this is a huge document that you cannot put in a single record, right? So you have to chunk it out, but at least you're chunking it in a way where there is some overlap between two records so that that context is getting preserved when you are transitioning from one document entry to another document entry. So good chunks improve precision without increasing vector index cost. Fewer richer chunks beat blind 512 token slicing every time. So this is exactly the scenario that we just discussed. Then the silent vector DB tags. Now, again, very important. So the three dials that drive your vector DB bill, and most teams never touch them. One is too many vectors. Second is vectors are too big. And third is every query hits raw vector search, right? So each of these are independent problems, right? So when you have too many vectors, right? So let's say, for example, your logs, drafts, duplicates, right? They are all embedded. You would typically use a TTL and of certain interval of time based on the use case that you're solving for, and you would typically archive the rest. If you have aggressive metadata filtering, then that's probably the right way. But semantic chunking actually cuts index size without actually recall loss. Like we understand what is recall, right? So typically for a precision, for a fixed size k retrieval, right? So you are essentially the k value that you set, right? You are actually optimizing for your recall loss, right? You want to make sure that no piece of information which is relevant to this particular search query is actually lost out during the retrieval. That's the first thing that you want to do. So once you have solved for that recall problem, that's when you try to target the precision problem, which is now that given that everything which is even remotely relevant I have retrieved, now how do I make sure that I only find the particular ones which are relevant to this particular query? So that is the precision problem that we typically solve using re-ranking and all these kind of techniques. Vectors are too big. Again, if your vectors are too big unnecessarily, you are using a lot of dimensions in the embedding space, and you are essentially, first of all, burning a lot of dollars over there in terms of using a complex embedding model that is not even required for a use case, and you are increasing the storage size, because of which your vector db size that you're provisioning for also has to increase. So you are essentially taking a hit on both cost as well as latency also you are taking a hit on, because every time you're retrieving each record, there is that much more extra number of bytes that you're retrieving, because your embedding space itself is that huge. Then the last one is every query hits raw vector search, right? So metadata filters, BM25 first vector search are typically which are used practically in production. You will never see a practical RAG production system which is just running on semantic search, uh, because every domain has this particular set of keywords which are relevant and which has a different meaning in their particular domain, right? And you want to make sure that when you're doing the retrieval, you are not just retrieving on the basis of meaning of the query, but you're also retrieving it on the basis of certain important keywords which are there in your query. Maybe that particular keyword uh, is will be lost in the particular semantic search retrieval, but if you're using a hybrid retrieval technique, definitely it will be caught in that. So that's how you improve the accuracy. Typically 3 to 5x of the cost reduction is achievable without users even noticing any quality change, if you're basically optimizing for these three factors. Now, retrieval architecture, there are some latest techniques also which have come into the picture: hybrid search, MMR, and cross-encoder re-ranking and page rank, right? These are very popular. These are very latest techniques that are coming. So, one of
Can we
them,
take two questions before we proceed? We have
yeah,
two
yeah,
questions,
please.
right?
Okay.
So the first question is, at production scale, what breaks first in RAG? Retrieval quality, then there is a bracket, chunking, drift, misranking, or infra bottlenecks, vector DB, comma, network, comma, LLM. And how do you pinpoint the root cause? Are you able to see that on the screen?
Yes, yes, I am able to see.
Right.
So, this is a very good question, by the way. So, the way I would put it is, quality retrieval quality to a certain extent is something that is solved for during the build stage itself, during the development stage itself. If you're talking about putting a rack system into production without having good evals pipeline already in place that you are evaluating for even during the build stage, right, then that's anyways not going to work out. That's definitely you're taking the wrong approach. So the retrieval quality more or less is typically solved for during the build stage itself. I think the cost and latency are two aspects which typically break in production at scale. Either your budget, the cost that you're incurring for running that system in production exceeds your budget limit that you had provisioned for to run that particular system. It basically doesn't give you an ROI any after that point, right? It is essentially a cost for the company. It's a loss making product for the company. And then there is the latency aspect. I mean, imagine if you're going to a particular app, you're asking a question and it's taking more than 15 seconds to answer that. No one in today's world has the patience to wait for 15 seconds for that answer to be retrieved and given to you. So you want something which has to be ultra sensitive in terms of response time as well. So definitely, infra bottleneck is something that breaks first in production. uh, Quality retrieval quality would not be breaking to a certain extent beyond a point, right? Retrieval quality is something that comes into the picture only when you hit that scale, and there will always be this one-off edge cases that will come up, like the example that I started with. It was a one-off edge case. It did not mean that my evals pipeline were really bad. It just meant that that particular edge case I had not covered in the evals pipeline. So definitely vector DB scaling, network calls failing, observability aspects, by the way, is very important. That is also something I've seen a lot of rack system failing for. There is a certain wrong answer which is generated, and you're as a developer, we are not able to attribute it. Why did it happen? That typically calls for trouble, because then if you are operating in a regulated space like ours, it becomes very difficult to justify that kind of scenario.
Okay, so since you mentioned something related to observability, we also had one question on observability. What
Mhm.
are the must-have observability metrics beyond latency and token usage?
Okay, so I'll talk about my observability metrics that I typically look for. So latency token usage, definitely. Yeah, P90 is something that we track. You also tag for token usage. But another important thing that you look for is what percentage of the API calls are failing to the LLM. If it is a serving of LLM that you're using outside of your ecosystem, that is another aspect that you have to monitor, because most of these companies, they give you a 99% uptime, right? If you are someone who cannot afford that 1% downtime, or if you cannot afford even a single query failing, you have to monitor for that. What is the percentage of API responses from that LLM provider which is failing? Uh, the next thing that we typically monitor for is if there are any fallbacks that are getting triggered. So typically in a RAG pipeline, you will always set some kind of rules and fallbacks, right? If you are breaching any rule, you want to monitor those rule breaches and how often it happens, and if there are any fallbacks that are getting triggered. So let's say a typical fallback for a customer support use case would be your chatbot is not able to answer the query, so it transferred that particular chat to a actual human agent. So what we say as agent transfer. Now that becomes an important metric that you want to track. What is the percentage of agent transfers that are happening on a daily basis? So let's say you upgraded your model from X model version to a Y model version, and you suddenly see that your agent transfer rates have shot up by whatever 10%, 20%, right? So that's again something that you would like to track. On the observability aspect, another thing that I typically look for is, don't just see whether the end output was correctly generated or not. You also have to see whether the reasoning for that output generation was correct or not. You also have to see whether the right kind of tools were called or not for that output generation. And you also have to see whether the right kind of parameters, input arguments were passed to that particular tool call or not. So I'll give you one practical example. Let's say if you go to our chatbot and you ask that, what is my wallet balance, right? Now it can give you a pseudo right answer for this, even before, without doing an actual tool call, right? Without actually retrieving your personal data, it will say that you can check your wallet balance by going to this part of the app, right? But that is not what you want to establish. What you want is a function tool call should happen to the get wallet balance API. Also, while you're doing this function call, you have to make sure that you're doing it for the right wallet type. So in a regulated entity, if you have multiple wallets within the same account, you want to make sure that you're doing it for the right one. You, let's say if you want to fetch your UPI balance, you have to make sure that if the customer is asking for a certain bank account's UPI balance, you're fetching the data only for that. You're not fetching the UPI balance for that particular customer across 10 or 20 different bank accounts that they have. So these are just some observability metrics that I typically track in production.
Right. For accuracy, you mentioned P90, right? We also have P55, P99, which can typically be used for retrieval quality as well. Like we usually use thresholding. So basically, let's suppose you have k equals to 7, and most of the time, not all these 7 chunks are relevant. So probably using observability, you can also have your schematic scores traced, so that if something doesn't make sense, you don't even have to retrieve it. But again, so this is something that you can tackle while you're using re-ranking. So
Right.
there's one
So
last question.
either during that, I think another one is adaptive K retrieval, Tarun. So I think that's also one very good advanced technique wherein you're saying that I will never set any static value for K. I will basically during the runtime itself decide that, okay, uh, let's say these are the scores that I've gotten in. Let's say one chunk has a similarity score of zero point 0.9. The next one has 0.85, the next one has zero point 0.8, and then the next one's similarity score is zero point 0.5. Now what you would do is you will see the delta, the difference between each of the similarity scores, and you see that what is the point where the drop in the delta or the increase in the delta is the highest. So here the zero point 0.9, 0.85, zero point 0.8 similarity score chunks are all kind of similar, but the 0.55 one is definitely not similar. So in kind of use cases where your information space is very diverse and you don't really know whether a particular question needs to be answered, can be answered on the basis of a certain set k retrieve chunks, in that case you have two options. Either you make multiple LLM calls to basically iteratively improve the answer and try to get it into a working state, which increases the latency. Or you can say that, okay, I am going to go with the adaptive k retrieval, where I will never set any static value. It will be dynamically decided on the basis of the delta difference between each retrieve chunk similarity score. And then you can, when you do this kind of technique in a single LLM call itself with the same context, you can get the answer generated in one go.
Okay, adaptive K retrieval. So basically, it's
Yes,
like dynamically picking your top K.
exactly.
Cool. We have one last question before we proceed. This is a general question, but I wanted to know, is LangGraph genuinely used in production, or should I switch to some other framework?
See, this is a, so here's the question. So what you're asking, I would translate this into, should we use Spring Boot in production or not, right? Now this is a question again. It depends on how comfortable you are as a developer. I think uh, every developer has their own set of choices or the preferences that they have. A lot of this is also determined by the tech stack that you're using in that particular enterprise, if you're working in an enterprise setup, or the kind of tech stack that everyone else around you is also comfortable with. So is LandGraph used in production? The answer is yes. It is used in a lot of production systems that I have seen. uh, but is there a single correct or wrong answer to it? I can't really answer that. It's a very subjective question. Depends on the developer's own choice.
Cool. Those are the questions we have. Probably we can proceed.
Okay, cool. So I think, yeah, I wanted to touch upon the hybrid search. Dense plus sparse is not optional, right? So I think we have discussed this to a certain extent, that we want to do a BM25 based retrieval plus semantic retrieval, right? I think this is very similar to that. What you're talking about is in a hybrid search retrieval space. You're doing a dense retrieval as well as a BM25. Dense retrieval is essentially a semantic search, and BM25 is basically a sparse retrieval, basically a keyword based retrieval. There are certain keywords which have higher importance, and if they occur in that particular chunk, you essentially end up retrieving them. So that's one technique that is used very heavily in production. This is an actual implementation of hybrid search, basically. So yeah, uh, I mean, this is a simple code example where you're saying that you're using a sentence transformer model, mini LM basically, and then the cross encoder technique that we discussed about. So you don't look at chunks individually. You combine the query embedding that you have generated with the embeddings that you're trying to retrieve from the vector DB, so that you see how closely they are related to each other, not just on a similarity score, but when you combine both of them together, how much of a relevance do they produce. Then you say that, okay, this is essentially what you're saying, that in stage one, your bi-encoder recall had a 20 retrieval. Basically it was retrieving 20 chunks, and then finally you're restricting it to 5 using a cross encoder precision. And this is essentially that you do. So in stage one, what you are optimizing for is recall, making sure that anything which is relevant is not lost. You're retrieving all of them. And in stage two, what you're doing is trying to precisely find out which are the important ones from this retrieved set of chunks that you have done, and trying to optimize it and return a definitive static value of final k. This is one technique. Obviously you can add another stage 3 to this, which is the adaptive k retrieval technique that we discussed. So if you combine that also, then you are not setting a static value, but you are actually optimizing for based on the similarity score differences. So yeah, cross encoder pattern along with adaptive k retrieval is something that I personally use very heavily in production, and it works really well, I mean, practically. Then maximal marginal relevance. So without MMR, dense corpus hands the LLM 5 chunks that say the same thing, right? So essentially what you want is, you want variety also in the retrieval. So let's say you ask a kind of question where you are asking certain keywords. So let's say I ask a question, what is my wallet balance in the equities market. Now this can have wallet balance in equities market, wallet balance in commodities market, wallet balance in that. What happens if your wallet balance is not showing the correct value? You can have so many different FAQ documents which are written, right? What you want to optimize for is the variety in retrieval sometimes. So you want to make sure that not the same kind of information is retrieved in those entire k chunks that you're retrieving, right? So take an example, this one that we are, so without MMR in that first example that we had taken, right? Why am I not able to sleep on time? So it will retrieve chunks like screen time causes sleep disruption, screen use before bed harms sleep, blue light from screen disrupts sleep, device use impacts sleep quality, and phones in bed cause sleep duration, right? So your LLM actually receives 5 identical ideas where the coverage is actually minimal. But if you deploy a maximal marginal relevance kind of a technique, right? What you're talking about is variance in the kind of chunks that are retrieved. So the first chunk talks about screen time causes this sleep disruption. Then melatonin suppressed by blue light is something that causes sleep disruption. Then replace screens with reading or audio, basically on the solution side. You're also talking about the solution here now. And then blue light glasses reduce disruption again on the solution space, and grayscale mode reduces screen appeal. So this will give you a more comprehensive answer to the question that you're asking. Like you're not just answering that question, but you're also giving solutions to how to overcome that problem of unable to sleep on time. Like, this is a very personal problem though, no, not able to sleep on time. So this is a hyper personalized example that way. But yeah, this is another example. Like if you use this kind of technique, it helps you in generating responses which are more varied. Cross
Also,
encoder
as a
re-ranking.
promotion, like I mean, sorry for the disturbance. So I've also linked the article where I've written in detail on how you can implement MMR. So I've also broken down the math behind it and how it can be useful in your search technique instead of semantic search. So if anyone is interested, probably you can also read this in detail. I've added it in the chat. It will also be in the description. Yeah, over to you, Indranil.
Yeah. So this re-ranking technique that we are talking about now here is again the code snippet that you saw here, the stage 1 and stage 2. That's exactly what we are talking about here. So in by-encoder retrieval, basically you're optimizing for recall. You're making sure your whatever the top 200 chunk candidates or whatever, you're retrieving it quickly, and then you're essentially doing a cross encoder re-ranking to make sure that out of these 200 candidates that you have retrieved, what are the top 10 chunks which are most relevant that you want to feed into the LLM context. So that what gets fed into the LLM context is just this 10 chunks which are the top most relevant, not actually the all 200 chunks that you're retrieved. If you just use this, you would typically end up losing out on a lot of good information that you should have retrieved. If you just use this, you will end up polluting your LLM context with a lot more information and context than what is actually required to answer. So that's the difference. That's why both of this together actually works really well. You optimize for both precision and recall at the same time. By the way, classical ML is still very, very relevant. Even if you're designing a GenAI based system, if you use the fundamentals of classical ML, you will still be able to solve most of the problems. Like it doesn't have to be, everything doesn't have to be prompt engineering. A lot of it can be solved using the classical ML techniques as well. Now, this is one very important technique which has recently become popularized. That's called page rank in RAG. So it's like a graph RAG, but a little bit of a advanced one that way, right? So basically, semantic similarity ranks by proximity, but page rank actually ranks by structural importance within the knowledge graph. So think of it this way: if you are a researcher or if you're an analyst, right, and you are given a certain book and you're asked to answer a certain data point in that book. Let's say you are given an IPO filing document of a certain company, and you are asked that what has please plot a revenue of this particular company for the last 5 years, right? Now, do I have to basically go over this entire document to really do this retrieval? The answer is no. Typically, an analyst or a researcher, what they do is they will go through the index first, the table of content. They will see that where exactly are the revenue data recorded in this entire book. So let's say they find out that it's on page number 200. They'll go to page number 200. Now within this page number 200, they'll look for that particular subsection. Now within that subsection is where they will find out the data, and based on that they will answer this question, right? Now this is typically like a graph problem, right? If you have a table of contents which is there with you, you would, instead of directly firing a data vector database query, right, you would typically be trying to infer it via multiple stages through that entire knowledge graph. And once you know that, okay, the answer lies in this particular node, that's where you will probably, if you want, you can fire a semantic similarity search or this thing to basically further reduce the context pollution by, you know, pinpointing only that particular piece of information which is relevant to you. So it actually works on the fundamental of iterative scoring, a structural centrality, a noise filter, and composable but not a replacement module, right? If you have a very large knowledge base with certain citation structures or technical or research document, this is basically the technique that you would use. I think most of the production rags which are working these days, which are working on with very large document spaces, I think they are, most of them are working in the with this technique only, page rank. Adaptive care retrieval, something that we discussed about. I think we have covered this in detail already, so we'll skip that part. But essentially there is another piece called as query optimization, right? I think we all know this, what we call as rewriting of the query that we do, right? So let's say the query is something that was very abstractly written by the user when they fired the query. You typically rewrite it in a way such that it can work really well with your embedding space and the vector DB retrieval that you're doing. The last part is latency at scale, right? Can 1 million PDFs be served under 1.5 seconds? The answer is yes. So you use ANN. ANN is fast, so we are ready. And but when you embed the query, ANN retrieval, all of those timestamps that you take into consideration, right? This is from an actual use case that I had built. This is how that how the numbers look like, right? So total, if you break down this entire latency piece into individual leg latencies, right, the total is still within the 1.5 seconds limit. Why do we say 1.5 seconds? Because for most chat system, I think that is the, like how for in the REST APIs, right, we typically target for less than 200 ms, because we say that a human brain typically identifies that as an instant operation if it happens within 200 ms. So similarly for most of the AI systems, I think if it's a chat based AI system, most of the time 1.5 second is the golden threshold that we work with. For voice system, it is a little different. There we still try to target for a 500 ms, less than 500 ms retrieval overall end to end. So yeah, so multi-layer caching using a Redis query embedding cache, top K retrieval cache, re-ranker output cache, final response cache. You essentially, every leg you can actually cache it somewhere if it is a generic response, if it's not a personalized response. And this is something that we use a lot in production. Like one of the example I can give is a lot of the queries that are fired to our customer service chatbot, they're actually greeting messages. Now, my response to the greeting message is never going to change. A greeting message will always have a greeting response, right? So if there are 100 users who are just coming to the chatbot and saying hi, I can just reuse that same response for every this thing. So at least the now when you are operating at a large scale, right, the number of high messages also that come into your LLM is a significant one. Even if it leads to a $1, $2 saving at the end of the month, I think it's still an important optimization to be done. And re-ranker as a GPU microservice, right? So you auto scale independently from retrieval, the re-ranker part, because re-ranking is something that you're doing post retrieval, right? So you want to scale that up independently, and you typically use a FV16 if you want if you're typically FV16 works well. I mean, you don't have to work with FV32 or the 64 bits for every operation. It works really well, and you can use batching and CPU light filter first before feeding it into the GPU cross encoder for the second iteration. Self-improving RAG look, I think this is where we are going into the accuracy part. So like for our chatbot, this is something that we had established. You ingest a new document, you create a lot of synthetic QA generated test cases, and then because for every response that is given by our chatbot, you are essentially we are also capturing a thumbs up, thumbs down for that response. I think this is something everyone does. OpenAI, Anthropic, everyone does. They have that thumbs up, thumbs down feature. So based on the thumbs up, thumbs down feature, we basically run eval loops and label failures. And sometimes there are certain failures that we also take it to the customer service team for a manual review. So let's say every time we get a thumbs down response, right, that is something which is fed into a feedback loop, wherein you can then quantify whether this is a genuine, first of all, a true positive thumbs down, or the customer gave thumbs down just because he's frustrated, right? If they're frustrated and they're giving a thumbs down for even a correct response generated by the chatbot, then that's not something that you want to feed into the loop. So a lot of this auto applying changes is something that we do, and a lot of this also we flag it for a manual review before we take it back into the feedback loop. Two failure modes, right answer existed but wrong chunk surfaced. I think this is something we discussed in detail. Poor chunking strategy, wrong embedding model, missing hybrid retrieval, and k too small for the query type. These are typically the problems that happen when this kind of scenarios are happening. And the another problem is bad prompt, right chunk retrieve, but the LLM has hallucinated anyway because they're really given a bad prompt. So that would typically be a problem where you would take it up for either prompt optimization using something like a DSPY and this kind of libraries, or you would say that I don't want to do all of that. I would rather do a fine tuning of this model so that it works really well for my use case. So context window too large. This is one example. Citation enforcement missing, system prompt under constraint, model not grounded in retrieve context. These are the kind of scenarios that happen in that. Citation enforcement missing is something also that we have faced in production, because for any regulated entity, any answer that is generated, it has to be backed with a particular citation. Otherwise, I will never have observability. So citation is the first most important requirement. If any answer is generated without a citation, then that's a recipe for disaster. We have to enforce that. RAG as justification. So 3 patterns that make RAG auditable. Deterministic chunk IDs. For every chunk that you're retrieving from the vector database, it should correspond with a unique chunk ID. So one thing that we do very religiously is never do a upsert in the vector database. Every time we are basically doing updating a particular doc ID which already exists, we would rather remove that previous version of the doc ID and insert this new doc ID with a different record ID. So every time, even though they both of these record 1 and record 2 correspond to the same doc ID, during the retrieval I am also recording the record ID so that I can always go back in time and trace out that this was done on this version or copy of the data, the time travel capability. Citation first prompting, again, if you are operating in a regulated industry, it is very important. And immutable evidence store, like the one that I just talked about. So you cannot update in place. It has to be a different version of the copy that will be done, so that at any point in time, if I were to go back and trace anything or look into the observability aspects, I have that copy of the data stored somewhere, so that based on that I can give the exact now, this is basically the final summary of everything that we discussed. So every decision is actually mapped to one of the 3 tiles. Your chunking strategy is something that is optimizing for your accuracy and cost. Your embedding model is something which is optimizing for accuracy and cost. Your hybrid retrieval is something it is optimizing for accuracy and latency. MMR re-ranking for accuracy, latency. Page rescoring for your page rank rescoring for your accuracy. Then there is cross encoder re-ranking for accuracy and latency. Multi-layer caching for your latency and cost. Hence it is a little bit of an engineering heavy task and less of typically a ML task. Self-improving eval loop, and then auditability and chunk ID, which is a compliance risk basically that you have to solve for. So as I say, no single tile is independent. Demo systems typically optimize for one. Most of the cases it's always accuracy, but production systems have to balance all 3 out and simultaneously, continuously under the real load. You have to optimize for all 3 of them. That's pretty much it from my side for today, guys. So, as I say, always build it, own it, and ship it. I think building is one part of it, but you also have to own it and ship it and maintain it in production. I think that's a different skill set altogether. And it's not just about the best embedding model or the largest vector DB. It is about judgment applied at every layer of processing that is happening on that piece of data before you generate the final answer. And you have to do it consistently in production for you to be able to answer. I think it's a very conscious choice that I didn't want to obsess too much about a particular vector DB during this talk, because it's important to highlight that that's the next level of optimization that you get into. But if you don't get these fundamentals right, I think you can use the most advanced vector DB that you want in the market right now, but your system will still fail if you're not engineering the right way. It's like MySQL DB versus NoSQL DB, right? Which one do you want to use, right? SQL versus NoSQL, right? It doesn't matter if you're not solving it the right way. If your use case itself is of a NoSQL, no matter what Postgres SQL you use or MySQL that you use, it is going to fail if the pattern itself does not fit there. So yeah, that's pretty much it from my side. We can start taking in more questions now.
Right. So we do have two questions. So this was actually taken during the ANN slide that you had. So ANN
Okay.
retrieval includes HNSW technique question mark.
So are we talking about
ANN probably it was during when you
ANN?
had
Yeah,
docs.
this one.
Yeah.
Yeah. So
So
ANN.
ANN,
So
yeah,
this is yes, it is true. You are essentially talking about a dense retrieval when you're talking about ANN retrieval. So yes, it does include that.
we have one more question. How do you prevent stale embeddings from degrading retrieval quality when data changes daily?
Okay, so again, a very practical, important question for a production system. Uh, how do you deal with stale embeddings, right? So here's the thing. So think of it from a perspective of if you're designing for any entry to be done into, let's say, something like a Redis cache, right? You always set a TTL because you know that whatever you're setting, the value here is not going to be there forever, right? So the way we do it, there are certain type of records which are slow changing. There are certain type of records which are constant, and then there are certain type of records which are fast changing. So, for example, uh, your news articles example that I was talking about, right? If I am feeding the news related article into my vector store pipeline, right? Every day a new piece of information will come in, right? So typically if you're asking the question, what is the general sentiment about a certain stock in the market, right? The answer that is generated today will probably be different tomorrow because of certain news that is published by that particular for that particular stock, right? Now you know that here the information that is held by this particular record is not going to be relevant tomorrow. So there are certain records wherein inherently when we do the ingestion itself, we set the TTL. For this type of record, let's say for news type of record, even in news, let's say the market updates, whatever the category of records are, I know that it is not going to be relevant tomorrow morning. So all of those records are going to be taken out of your vector store by tomorrow morning, 8 o'clock. So post tomorrow morning 8 o'clock, because the market is now going to open and the scenarios are going to change, the basis of that information will probably change. We don't want to take that risk of context pollution. We just want to keep a clean slate and let it start from scratch. I would rather say that I am unable to give you the sentiment right now than give a reverse sentiment or give a wrong sentiment. Like I because for every sentiment that I give, I also have to give the reference article. And if I'm giving a reference article which is, let's say, 1 month old or even a 1 day old, right, it kind of puts us into trouble from a regulatory perspective. So you have to avoid that. Do we have any more questions?
So we don't have any questions as of now, but if anyone has any follow-up questions of whatever questions I've asked, you can let us know. But we are also reaching the time. Do you have any closing thoughts until we have any follow-up question?
So I think one thing that I would like to highlight is I think there's a lot of discussions and talks which are happening around the agentic AI systems, right? Uh, which is fair enough, but I think for the agentic AI systems to work well, right, your individual agents still have to work well, right? And most of the time for an enterprise use case, your individual agent is always an independent rack, if you look at it. Because most of the enterprise use cases, you always have to ground any particular agent to your enterprise context, which is where your rack system comes into the picture. So if you're not optimizing that smallest unit of that agentic AI architecture, which is a RAG system, you are essentially setting yourself up for failure. Like you would typically, if you're not optimizing the RAG, what you would do is, okay, in my agentic AI architecture, let my this particular agent produce any wrong output, and I will keep on reiterating and improving the quality over time. That typically does not scale well because of the cost that is incurred in that process, right? So for an enterprise use case, everything has to go through a cost benefit analysis. If you have to do 10 iterations to produce the same quality of output that you could produce in a single iteration just by doing a good rack system, then it's something that you're doing wrong on the engineering side. I mean, the bi encoder plus cross encoder, the recall optimization plus precision optimization, and then you feeding into the LLM context. I think that is a classic case of that. You cannot use either one of them. You have to use both of them together and then feed into the LLM context for you to get the optimal output. I think that's pretty much the closing thought. I think RAG is little bit flying under the radar, but I think most of the production systems which are working really well are still optimizing for the individual RAG agents that they're building in the overall scheme of agentic AI architectures.
All right. So that is it from this particular series. So again, if you want to reach out to Indranil Chandra, you can directly reach out to him on LinkedIn. And we'll also be doing more this videos because I don't want to stop at just 3 videos. So if you have any challenges that you want us to have an entire live session, probably you can send us a request on the Discord server, and you can find all the Discord server links in the URL. And not just that, we will also be sharing the source code for this particular session so that you can get your hands on at least some of the techniques that was mentioned in this video, right? Even if you are using smaller part of it and then switching it in your code bases, it can also make much difference. So we'll also be sharing those details in the description within few days. And yeah, regarding the next video update, we might have something related to how to handle function calling when you have more than 1,000 tools, because we have one startup who handles that particular function calling part. But again, I don't want to confirm the dates as of now until it is confirmed by the speaker. So let's just keep that in suspense. But yeah, this was the update about the next upcoming live stream, which will be on how to handle multiple function call in your entire pipeline. So yeah, that is it. So again, Indranil, thank you for your time in showcasing the demo and as well as sharing your knowledge. I hope it was insightful to the community. Until next time,
Thank you.
I'll end the stream.